Here we go. Yeah. Very good. We're at 12:30, so I'm going to start. So, everyone, I'd like to welcome you to the 2020 Cold Spray Action Team Conference Meeting Discussion Workshop. So, depending on where you are across the globe, good morning, good afternoon, good evening, again, we welcome your participation. Those of you who know me realize I enjoy a live audience, so this virtual event is certainly going to be a challenge for me. I want to, again, thank you for your participation. This is unprecedented numbers that we've achieved, over 716 registrants. And again, I want to take the time to thank Solvis Global for making this event possible. Without them, we wouldn't be able to have this event, and we'd have to postpone it until 2021. And by the way, we do have, God willing, a date locked in, June 22nd and 23rd. And while I'm uploading my slides, Dr. Aaron Burt will just go over protocol for today's event in terms of questions and how we're going to deal with the discussion part.
Perfect. Thank you, Vic. All right. So we're going to have about 19 presentations here, and the goal is to have about 10 minutes of speaking and then 5 minutes of Q&A. So for those of you that have questions throughout the person's talk, by all means, post those in the Q&A. Those will get filtered to the moderator, and the moderator can take care of passing those on to the presenter to make sure those questions get answered. We'll try to take about 5 minutes for the Q&A, so we may not get to everything, but we will get to as much as we can. This is a packed agenda, so there won't be a specific break point, but if you need to take a break, by all means, step away. We're not going anywhere. We're here to make sure that you guys get the best information that we can get you in the world of cold spray. And so with that, you won't have access to your microphones. That's intentional because there's going to be over 700 of us on here. But if you do have a question, again, technical or otherwise, feel free to post it in the Q&A, and we'll address it as is needed. We'll keep everybody on track. So for my presenters, you'll hear you will see an 8 and 9.5 minute warning in presenter chats, and then when we get to the 10-minute mark, we'll start to just recommend that we move over to Q&A. We'll keep you on point there so that we don't. But otherwise, this should all run pretty smoothly. Kudos to the team at Solvis for getting all this together, and hopefully for being able to have both DoD and non-DoD here. That's going to be a big deal for us here. So very excited, and I think that should be all of the major points for just kind of order here. And Vic, whenever you're ready, we can have you take it away.
All right, excellent. So I'm on to my first slide, the introductory slide.
Real quick, the slides aren't shared yet.
Okay. All right.
Now you're good to go.
Excellent. All right. So a snapshot of what we're going to see today. I don't want to dwell on these at this point in time because I only have 10 minutes. Aaron Burt set the table pretty well. You're going to hear talks about transition, applications development, all sorts of programs from past, present, and future. You'll hear the tri-services. You'll hear industry. Try to hit topics that we're all interested in terms of advanced materials and new cold spray processes, machine learning in regards to controls, obviously inspection and hardware. Again, it's very truncated, but we're doing our best to give a good snapshot of what everybody would be interested in. So, if I go back in time, this is the vision I had conceived years ago. when we first started, and it's over 20 years that we've been developing this technology. And I've broken it up into 3 phases where initially you're talking, you know, the late 80s, early 90s, we're just trying to enable cold spray. Can we take it from a laboratory curiosity and put it into a production environment? And we were successful at doing that. And then in phase 2, okay, besides these cosmetic non-structural repairs, you know, can we start to carry load? Can we put a cold spray deposit in a fatigue scenario, right? And so we developed those sort of processes and introduced them. And then gas consumption. We found out that helium gave us our best properties, but helium, very finite commodity, expensive, right, over oxygen or nitrogen gas. And so we developed the helium recovery system, and I'm proud to say a couple of things about that. Number one, the system in Webster, Massachusetts that was put together by a research team involving a number of industry, government, and laboratories, United Technologies, ARL, Quantum, DRC, Mode. That's operating at about 95% efficiency, okay, and the purity level can be as high as 98, 99 plus. And so that's working very well, and that's a game changer. One of the things I do want to announce, the ASM will announce it, but I've been selected for the ASM Engineering Achievement Award along with the rest of the team. And so we're very proud of that. That's a monumental achievement for all of us. So without the team, these things wouldn't be possible. And then we're in our phase 3 now, where we're developing advanced automation. You heard me talk about machine learning. Aaron Burt from Solvis will be discussing that in some level of detail on how to incorporate that and control our process with higher fidelity, precision, repeatability, reliability. These are the things that we need for additive manufacturing. The holistic approach to cold spray development was the way we made this happen, all right? Certainly not enough time to dive into each one of these technical pillars, I'll call them. But I will say one thing, that you know, garbage in, garbage out, that old computer adage, right? And that's the approach we're taking. You've got to start from feedstock powder. You've got to develop processes for handling, for engineering, for shipping, for storing, for using powder, along with hardware, software development, controls, advanced processes, and obviously, you know, characterization. All of those lead to transition. All right. So it's a little comical. I've shown these a number of times throughout the years, but we've certainly bridged that valley of death. All right. There will be enough of testimony you'll hear today and you've heard through the years. It hasn't been an easy road, and that's basically what these cartoons are showing. Cold spray qualification in the beginning took me 7 years to get the first aerospace application approved, and that was actually lightning speed. If you look at emerging technologies, NASA has a good description on how you go from TR level 1 to TR level 9, and that's usually a span of 20 years. We did it in 7, and once those 7 years were up, and we got our first application in, the rest just fell into place. It was like the snowball effect. You see this next slide. Cold spray is being used in all of these different industries. Now, I usually take time and kind of brag about some of the achievements for the year. And so I do want to introduce a couple of things. By the way, what I'm introducing now can be pulled off the internet in various talks, these data happen to be contained in a report that's online. It's from CERTA, and actually the next slide will give you the HTTP address. But I never thought this would be possible like 20 years ago. That would be going head to toe with thermal spray, and not even head to toe, much better now. The coatings for chrome nickel replacement, much tougher. Wear resistant is phenomenal, and being commercialized as we speak. And some of these can be sprayed with nitrogen. This just goes into a little bit more level of detail. You're going to hear presentations today speaking towards these WIP coatings, wear, impact, protection. That's what WIP stands for. And these are being sold commercially right now. And you can get these off the shelf from Solvis Global. They represent years of development. And you see some of the, like shear strength values, phenomenal bonding, really nice dense coatings, very good wear resistance. And you see the final report was posted this past year, and anyone can download those. So I want to end with something appropriate. In this pandemic that we're facing, it's interesting to note, and I tried to get widespread adaptation of some of this work that I did, others did years ago. I mean, there's a video that you can access. Actually, it's an interview with me in 2010, reporting some of the results of copper antimicrobial coatings. And so you see copper masks, you see copper socks, you see all sorts of different products being made by copper. And this goes back to the Mesopotamian and ancient times, where as soon as we started, man started working with copper, he probably obviously didn't know why, but he knew that it had some sort of, I won't use the word medicinal properties, but basically copper kills, all right? And you see some of the results here. This happens to be a chart showing the kill rate against MRSA. It's been shown to kill viruses. It's been shown to kill the coronavirus even. And so you see the collaborators we worked with years ago, and this goes way back. This goes back even beyond 2010. But the use of stainless steel is prevalent. You see in hospitals everywhere, right? Because stainless steel looks pretty. You can use disinfectants on it. It cleans up well, but its kill rate is very poor, very poor. And so, if you go back in years ago to even my grandmother's house, they had old brass fittings, brass doorknobs. We went away from that, so we need to go back. So this is just showing that copper cold spray coating, copper has been registered with the EPA. I think there's over 300-400 alloys right now that are registered with the EPA. And I'm going to end with this one, my buddy Tom Brady. And so years ago, what really spurred this work was the fact that folks were dying from staph infections, that were acquired in hospitals. And basically the bottom line up front is if we copperize, if we use more copper and copper-containing alloys, we can mitigate the onset of infections. We can kill bacteria on touched surfaces. And so that's the moral of this story. I did put at the time when this event occurred. So basically, Tom Brady was brutally attacked by a member of the Chiefs, and this is for those Chiefs fans. And anyway, he ended up, tearing a ligament, having a surgery, getting a staph infection, and lo and behold, the moral of the story is if we had used copper, it may have mitigated that event from occurring. And this is some of the results. I believe this is my last slide. What's interesting is the International Thermal Spray Conference in 2021 is focusing on coatings for antivirus, bacteria, and fungus using thermal spray. Well, if you pull some of my old papers I did with research team, folks from WPI, Kristen Sundberg was one of the PhD candidates I had worked with, and then even before that, Dr. Dennis Helfrich and I, we compared plasma spray, wire arc spray, and cold spray, and you see the kill rate of cold spray is magnitudes, order of 3 magnitudes better than thermal spray. So not to throw my thermal spray colleagues under the bus, but I think we need to include cold spray at that conference. I don't see any talks on cold spray. Last slide, you can access some of these. Some of these go way back, like I said, 2010, 2013, 2015. So this is not a knee-jerk reaction, to the current pandemic. This research was done before, and actually a lot of this should have been implemented. So without any further delay, I want to introduce to you Dr. Rob Carter. He's going to be giving you a roadmap from the OSD perspective, and I will exit out of here, and Dr. Carter can